Welcome to this training session on Information Systems Auditing Process Execution. Today, we are moving beyond the planning phase into the action phase execution with a specific lens on how audit project management ensures success. We will explore how to manage the audit like a project, gather irrefutable evidence, and rigorously test controls. Let's get started. Let's begin by positioning ourselves within the audit lifecycle. You've completed your risk assessments and defined your scope. Now we enter the execution phase. This is where the rubber meets the road. Simply put, execution is the active process of gathering evidence and testing internal controls to verify if they are working as intended. It sits right in the middle of our life cycle, bridging the gap between the theoretical plan and the final report. We must view this phase through the lens of project management. Why? Because audits use resources, your time, the auditee's time, and budget. Without project management discipline, audits can suffer from scope creep or delays. Our ultimate goal here is to gather sufficient reliable evidence to form a solid opinion on whether the organization's information systems are truly protected and effective. Looking at the diagram, you see the flow of the audit lifecycle. We transition from audit planning on the left, which is driven by risk assessment, directly into our focus area, audit execution. Note how execution is not a single step but a trifecta of activities: gathering evidence, evaluating controls, and validating results. These interconnected tasks must be completed thoroughly before we can move to the final node, reporting. This visual underscores that execution is the engine that drives the audit findings. Now let's deep dive into audit project management. An audit is, by definition, a project. It has a start date, an end date, and unique deliverables. You must manage it using standard project management process groups: initiating, planning, executing, monitoring, and closing. A critical aspect here is resource management. You don't just need bodies, you need specific skills. If you are auditing a complex firewall, you need a team member with network security expertise. As an audit manager, you are constantly juggling the triple constraint: scope, time, and quality. If management asks you to add a new system to the audit, increasing scope, you must explain that this will either take more time or require more resources to maintain quality. Effective project management also means constant monitoring, using tools like Gantt charts to track milestones and ensuring you aren't falling behind. This diagram illustrates the classic triple constraint or iron triangle of project management applied to auditing. At the center is audit quality, our non-negotiable goal. Surrounding it are the three constraints: scope, time, and cost resources. The lines connecting them show their dependency. You cannot change one point of the triangle, like expanding scope, without pulling on time or cost. If you try to fix all three rigidly, quality often breaks. As an auditor, you manage these tensions to deliver a high-quality audit report. Execution is largely about gathering evidence, but not just any evidence. It must be competent, meaning it is valid and relevant. Think of the evidence lifecycle. We identify what we need, collect it, preserve its integrity, especially for digital forensics, and then analyze it. We gather this from various sources. We observe processes in action, like watching a data center entry procedure. We review documents like firewall logs or security policies, and we conduct interviews. Crucially, you must understand the reliability hierarchy. Evidence you observe yourself is stronger than what an auditee tells you. Written documentation is stronger than oral explanations. And evidence from an independent third party is often the most reliable of all. This pyramid diagram represents the hierarchy of evidence reliability. At the base, we have oral representations. This is the least reliable form. People can misremember or mislead. Above that is internal documents created by the auditee. Higher still are external documents, like third-party confirmations, which carry more weight. At the very peak, highlighted in green, is auditor observation and re-performance. This is the gold standard because it relies on your own direct verification, not hearsay. How do we actually get the evidence? We have a toolkit of techniques. First, reviewing documentation helps us understand the should-be state. What do the policies say? Then we use inquiry and interviewing. This isn't just chatting. It's a structured technique to uncover risks. We use open-ended questions to get the auditee talking. Observation allows us to see if practice matches policy, like checking if users really lock their screens. Re-performance is highly effective. Here, you don't just watch, you do the calculation or procedure yourself to prove the system's accuracy. Finally, walkthroughs are essential for understanding complex flows. Tracing a single transaction from initiation to reporting to see every control it passes through, this mind map breaks down our collection techniques. Central to the diagram is the concept of collection techniques. Branching out, we see our four main tools. Review docs leads us to examine policies and standards. Observation focuses on actual processes. Interviews help us gauge staff awareness. And reperformance is our path to validation. Each technique gives us a different piece of the puzzle, and often we must combine them to get the full picture. Once we have evidence, we test it. We have two main gears, compliance testing and substantive testing. Compliance testing asks, is the control working? For example, we check if the change management board actually signs off on changes. Substantive testing asks, is the data right? Here, we might check if interest calculations are accurate to the penny. There is a balance. If compliance testing shows controls are weak, we must ramp up substantive testing to ensure no material errors slip through. Since we often can't check everything, we use sampling. Statistical sampling gives us a mathematical probability of error, while judgmental sampling relies on our professional experience to target high-risk items. This flowchart helps you decide on the testing methodology. It starts with assessing control risk. If reliance on controls is high, meaning we trust the system, we proceed down the compliance testing path to check if those controls exist and operate effectively. If controls are weak or missing, we shift to substantive testing to verify the actual data accuracy. Both paths ultimately lead to a result, but the route depends on your assessment of the control environment. In the modern era, manual testing isn't enough. We leverage data analytics and CAATs, computer-assisted audit techniques. These tools allow us to ingest massive data sets from diverse systems. The game changer here is that CAATs allow us to test 100% of the population, rather than just a sample. We can instantly spot every transaction over a certain limit or find duplicate payments indicating fraud. We might use generalized audit software, GAS, or set up continuous auditing where the system alerts us to anomalies in real time. This shifts us from reactive auditing to proactive monitoring. This diagram visualizes the CAAT's workflow. We start with raw data on the left, which is imported into the CAAT's engine. The engine performs three key functions: filtering for exceptions like unauthorized access, analyzing trends over time, and verifying 100% coverage of the data. These outputs, especially exceptions, flow directly into audit action, allowing us to target our investigation where it matters most. Once tests are done, we must validate and document. You cannot just report a feeling, you must prove it. We structure every finding using the 5 Cs. Condition, what we found; criteria, what the standard says; cause, the root of the issue; effect, the risk impact; and recommendation, the fix. This structure ensures clarity. All of this goes into the audit work papers. These papers are the legal and professional record of the audit. They must be complete enough that another auditor could repeat your work and reach the same conclusion. Finally, supervision is key. Senior staff must review these papers to ensure audit quality before the report goes out. Here we see the anatomy of a solid audit finding. The central node audit finding branches into the 5 essential components. Notice the relationships. We compare the condition, what is, against the criteria, what should be, to find the gap. We analyze the cause to derive a meaningful recommendation. Understanding this structure is vital for writing reports that management will actually respect and act upon. We conclude execution with communication and closure. The golden rule here is no surprises. You should discuss findings with management as they arise, not dump them all in the final report. This culminates in the exit interview, a formal meeting to agree on the facts and discuss remediation timelines. Following this, we issue the draft report for comment. But we aren't done yet. Project closure involves archiving your work papers securely and evaluating your team's performance. Finally, we plan for follow-up to ensure that the management actually fixes the problems we found. This completes the audit project cycle. This cycle diagram shows the communication flow closing the loop. From execution, we provide interim updates to management. This leads to the exit interview to confirm facts. Then the final report is issued. Crucially, the arrow from follow-up loops back. This represents verifying the fix. If the fix fails, the cycle might restart or lead to a new finding. This ensures the audit provides lasting value, not just a document on a shelf.